application part of electrochemistry. So today we are going to discuss about commercial cells and the batteries that we are using in our day-to-day life. And battery. See, the word that I have written, it is wrong. But it is being told like this only. Because it's singular, battery does not have any singular word. Battery itself is a plural word. But it is, everybody use the name battery. But actually battery itself is plural. Okay? So now, let me write the definition of it. Galvanic cells or voltaic cells. So no, I'll change the definition. I'll write another definition. Battery is a group of electrochemical cells where chemical energy of a spontaneous redox reaction is converted into electrical. This is the definition. So, but there are so many things are, I mean, you can have many types of electrochemical cell which is going to produce electricity. But what type of cells we are using as a battery? So we should write now. Characteristics of battery or cell. First of all, battery should be very light. You should be able to carry it from one place to another. Okay. It should be light and compact. So that it can be used as a portable electric generator. This you can carry anywhere. It should be light and compact. All the batteries that you have seen in your life are very, very light and compact. Thank you. Its voltage should not vary appreciably. Should not vary appreciably during its use. So all the batteries which are using it, whether be it in torch or any other thing, you find suddenly the light does not become dim. If it is so, then you change the battery. Right. It should have reasonably long life. Should have reasonably long life. When both when it is used or not in use. See, this is except mobile. Mobile said we are using it, but all the time we do not go for talking and all this thing. So whenever you keep it also, it is going to stay for some hours or some time. So these three are important for your exam also. So please remember, I try to have write it in as simple as this way.
Sir, can you read out the third point?
It should have reasonably long life when both where it is used or not in use.
Thank you, sir.
It's live LIPE, LIGH. So what's that after long?
It should have reasonably long life
Okay, sir.
when it is used or not in use. Types of batteries or commercial cells. 1. Primary cells, batteries. Secondary battery cells. Secondary cells or batteries. in these cells, electron reactions cannot be recovered. I explain everything. Cannot be reversed by an external electric energy source. In this cell, reaction occur only once. And after use, they become dead. Dead. Therefore, these are not rechargeable. That you have seen, you taught cell you to throw, na? Example, torch cell is called Bryson. Then, second one that you are using in your watches, mercury or button cells. In these cells, the electrode reactions can be reversed by an external electrical source. Therefore, these cells can be recharge by passing by electric current and can be used again and again. These are also called, because you can keep it for a long time, nah? So anything you can keep for a long time, you can store it. So these are also called storage cells. Example, see the battery that you use in your car, automobiles. Okay, we call it lead storage cells. Then we use nickel cadmium cells. Nickel cadmium cells. These days we are not using nickel cadmium cells. These days we are using lithium cadmium cells. Okay, in mobiles, etc.
Done, sir.
তুমি যে পেঁপেটা ভালো আছে বুঝলে, তুমি কিন্তু ছেটকি কাটবে বলেছিলে, এটাই ভালো, কিন্তু কখন কাটবে?
Hey, sleeping or what? Finish.
Yes, sir.
Then
So,
why you are keeping quiet?
so we just
Good,
finished.
sir.
Just finish, na? Sibun chalak. Okay, now we'll go for primary cell. My drawings are very bad. You do you have your textbook nearby?
Yes, sir.
Open
Yes,
the
sir.
textbook. Find out from electrochemistry dry cells. Okay. So first one we are going to discuss about primary cells. So we are going to example dry cell. Okay. So I shall try to draw, but my drawing is so bad. Okay. See, I have cut a section from here. Okay. And this is the one. You know what is called, better if you find, you know this one. Okay. I think none of you have broken the battery you have seen. But in childhood too, you used to see what is inside. Okay. So this is the one. Battery. See, these days, when we use battery, our battery was not leak proof. Battery was being simply covered with a thick paper. These days, you are using all the cells that you are using, these are leak proof batteries. Means what? Outside, they put a steel jacket. So this is the steel jacket. This is called leak proof. You did not draw it, or if you wish, you can draw later on. Now you try to understand the chemistry. This is the zinc. This it is a container is a zinc can. Can means container, and this act as a anode. Is the anode, and this is a graphite rod. Graphite rod. Okay, yes, cathode. Okay. Then inside you'll find just around the graphite you'll find a porous paper is there, and here also below that zinc and one porous paper is there. So that I cannot draw it. So in your book they have nicely drawn it. So now you will find it's being packed with some paste of some compound. So I'll write it here. A paste of manganese dioxide, ammonium chloride, zinc chloride, and carbon powder. I will discuss everything one by one. Okay. So as it is anode here, but here also find zinc is there. So I'll write it here plus, minus, and here I write plus. So this is the everything inside the dry cell. Okay. So I'm going to write the reaction. First I'll try to make you understand, then I'll write the final reaction. So see here, anode is zinc. I'll write now here. Reaction at anode. See, I am taking electrochemistry very slowly because it is not possible for you to understand simply by reading the book. Chemical kinetics is not difficult. Reaction net. Zinc gas. আমি কাটবো। Zinc 2 plus aqueous. Why should I write aqueous? Because it is a paste, it contains water. Plus 2 electron. Then this reaction at cathode I'll write later on. See now the chemistry here, very interesting. Here we are using ammonium chloride. Ammonium chloride is acting as an electrolyte. Electrolyte should ionize. See here. It is an electrolyte. So this one, when you write it now, in the main equation, don't write. You write it separately. When I finish everything, then this portion you write separately in a box. Electrolyte. Okay, now see, you know how ammonium has formed. Ammonia, when it comes in contact with acid, see here, you know how it forms. Does it not form here ammonium plus? It forms ammonium plus. All right. So what I'm going to write now? I'll write now here NH4 plus equal to NH3 and H plus. See, this H plus takes this electron to give you H. Hydrogen atom. Hydrogen atom is a very strong reducing agent. Now see here. What I have taken here now? Manganese dioxide. What is this oxidation state? +4. So this hydrogen reduces manganese dioxide to give you what? How can I write manganese dioxide? Manganese dioxide is this. So when it reacts with H, it will going to reduce this one of the double bond. So what you will get now here? You get this and you get this. See, this is +4, this is +3. What has happened? Though I have written with bold letter that graphite rod is the cathode, but actually here manganese dioxide is acting as a cathode. Okay. Who supplied electron to manganese? We know duty of the electrolyte is only to supply electron and they undergo decomposition. So here ammonium chloride is an electrolyte and manganese dioxide is acting as a cathode. Now see, how many electrons it is given? 2. So in that case, what should I do? I should multiply this by 2. How many hydrogen is produced? 2. So what should I write here now? Oh, okay. I'll write this formula here. MnO and OH I will put inside bracket C. Okay. So it has produced 2 hydrogen. So I'll multiply it by 2. But the hydrogen came from where? From ammonium. So I'll multiply it by 2. All right. So I'm going to write this one. I've shown you just to show the structure. So now I'll add it. Okay. So I multiplied by 2. All right. So I'll remove this, this, and this. So what should I write now? Achha, see, dear, I'll remove this electrolyte portion, because you know this is already going to give. So let us forget about this. Let us start with the, because redox reaction you always done with the this thing. Only thing you know, ammonium chloride is an electrolyte. Redox reaction we are doing iron, so because of that. What should I write now here? 2NH4 plus, then 2MnO2 plus, then what should I write now here? 2 electron. Then what should I write it here? 2 MnO. What is the name of this one? Don't get scared. Hydroxy manganese oxide. Okay? Plus what? 2 NH3. So this will write separately. So now this one I'm going to write it here. Reaction at cathode. So I'll write now here same thing. 2 NH4 plus 2 manganese dioxide, 2 electron. So here I'll write here 2 MnOH plus 2 ammonia. All right. Okay. Now what I will write now? In always cell you have to write overall reaction. Overall reaction, what will happen? This and this will cancel. So I'll write now here zinc S. So here I'm going to write aqueous electrolyte na. This one I'll write S. I'll write now here 2 MnO2S, 2 NH4 plus aqueous, and it will give you zinc 2 plus aqueous, then 2 this is solid plus 2 ammonia, this also will dissolve, you will get aqueous. So this is the overall reaction. Write down this one. After finishing this one, you write separately in a box. And here you write in the box, you write reaction at cathode. So this one, please first finish writing this reaction, because this reaction you don't have to write in your exam. It's only for your understanding, because chemical reactions are not magic. So first you write, then leave some space, then you write in a box what is actually happening there in the this. Right. This reaction, they're very interesting. We keep it for some time. So the question may come sometime, okay? That in dry cell, what is the electrolyte? So you'll write electrolyte is ammonium chloride. Who is acting as a cathode? Manganese dioxide and the graphite rod. Okay. So now see here. See what very interesting thing. What is being evolved there? Ammonia. A cell, if you buy it, going to last for one month or 2 months. So in this process, see, in dry cell or in electrochemical cell, reaction never stops, whether used or not. So much amount of ammonia gas will be evolved. Little amount may be dissolved in small amount of water which is present in the cell, but rest of the gas, it will remain there. So too much of pressure will be built up and the cell will burst. So in that case, this type of accident sometimes occur in mobile also because of the evolution of gas. So what happens now? See, why did you use this one? See, in this reaction, I have used this. I have used this, but we did not use this one. So what should I write? We'll write now. The ammonia gas, why it is liberated? Cathode. The ammonia gas liberated at cathode. Immediately combine with zinc chloride to form a coordination compound. Coordination compound or complex? Okay, forget. Complex word is better. Form a complex. What is the complex? Zn NH3. Okay, this is called tetra. See, TTRA again A. Tetraamine zinc, one word. Tetraamine zinc is one word. And then there will be a you do not have any danger of explosion. Immediately ammonia will combine with this. So I'll show you now the chemical reaction. Zn Cl2 4 NH3 will give you so this is the one that you are going to get.
এই ইয়েনোটা অন্য ইয়েনো একই নাকি?
The dry cell cells generate a potential of 1.2 to 1.5 volt. The cell reaction takes a lot of time to discuss. The two generally popular question is there with this one. One question it says why dry cell does not give constant voltage that you have seen in your house. If you are using dry cell in your torch, initially for few days it is very bright. Then gradually you find the brightness decreases because the voltage drops. So why dry cell does not give constant voltage? See here. In this reaction, see, this reaction is irreversible. Which one is undergoing decomposition? Who carries the electron? Ammonium chloride. As the concentration of the ammonium chloride decreases, the other conduction of the electricity also decreases. So the voltage drops. So the question is, why do dry cells why dry cells do not produce constant voltage? So what we will write now? Answer. with the passage of time, the concentration of electrolyte, inside there we write ammonium chloride, decreases. With the passage of time, concentration of the electrolyte decreases. Huh? Decreases. And hence,
ওই দিনের মতন আর হয়নি একটু করে।
and hence do not produce.
আমি তো ওদের জন্য
Or
বানাচ্ছি
do not produce and do not give.
এটা দেওয়া যায়
Do not give constant voltage. Or do not, even that do not produce. Do not produce constant voltage.
দিয়ে দিয়েছে
No.
ও কি আছে সাধারণ মানুষের বাইরে
অত লজ্জা করলে তা হতো না।
Done, sir.
Then now what is the second question that you have felt also? Why dry cells become soft or leaks with wrong use? Dry cell becomes soft and leaks. Acha, very interesting thing. Let me tell you one. Here only I am going to tell. So this one you can you should not do it, but you know that sometimes it become necessary. See here. Oh, I should not have rubbed this. See, in dry cell, this is a container made up of what? Zinc. Okay, outer level is acting as a anode. All right. So what is the equation now? It gives you this. So constantly the corrosion of the zinc takes place. By that way, what happens? The case becomes soft. And not only that, because of corrosion, leakage also takes place. Because of that, they become soft and leakage takes place. So what should I write now? In dry cell, the zinc can acts as anode and undergoes constant corrosion by which its thickness decreases and become soft or develop holes. If hole is there, leaking will be there. Finish.
page, sir.
Okay, now see. Now I'm talking about emergency. Say you want to go out, suddenly you take out the torch because we remember torch only when light is not there or darkness is there. You have gone somewhere, darkness is there. We remember umbrella only when it rains. Others we forget. So when you take out torch, you find only little light or the bulb has become only red. You can't see anything. What to do? Now you understood. The battery must be replaced, but that is the emergency. What will do? So if this is the battery, why you know what has happened? Yes, because the electrolyte is being constantly used, and this is the cell wall. What happens? Electrolyte gradually shrinks inside, and the direct contact of the zinc can with the electrolyte does not take place. So what you will do? You take a hammer or a plus and just press it. Moment you press, then the electrolyte, zinc can touches the electrolyte. After that, you will find your torch is glowing. Okay, this I have learned from a person who has no idea of chemistry. He told me, "Sir, you do like this." Then I was thinking, what should I do? Then what? Immediately he took it from my hand, and for him the shortcut. Immediately he given a strong bite on the this thing cell. So cell has become little deformed, but I found that my torch can be used for 1-2 hours. I could use it. Then I was thinking that why it has happened, because if this is the cell wall and this is the electrolyte, earlier it was in contact, but because of constant use, a gap is being generated. So zinc, even after losing electron, cannot send the electron to the electrolyte. So moment it is being pressed, it has come in contact and just function. So this is only for emergency. So don't make a habit of saving your money like that by risking your life. Okay. Now we want a cell. It may be primary, but it should give constant voltage. So I'll give you a simple example which you have observed in your life also. See, in our houses, every house is having wall clock. And in wall clock, we are using dry cells. It will function smoothly for 5-6 months. Then after that, you may find either your this wall clock is running fast or it has become slow. But the cell which you use in our wristwatches, it does not create such problem. As long as it can be used, you'll find it is going to give a correct time. But suddenly you'll find that your watch has stopped. That is, and in that case, you immediately have to go and replace the battery. Please remember, the cell which you are using in wristwatches, camera, and all these places, it almost looks like a button because of that we call it button cell. So that is also a primary cell, but it gives constant voltage. So I'm going to write now the second one. Mercury cell. Look at the book. Or buttons. Okay, here the here also you will find. Okay, I try to draw it. So again, my drawing will be very bad. This is the one. Okay. See here, outside is made of steel. Inside is made of, so we can write it here, steel jacket. And this is the zinc container. So you know what is this? This is here, unlike the dry cell, we do not have any do not have any, what should I say, graphite rock. Okay. So here it will be filled with paste. Here you will find mercury oxide is used as a cathode. Okay, cathode. And electrolyte is potassium hydroxide and zinc oxide. So I'll write it now. So reaction at anode. But this reaction you will not write now. It's a wrong reaction. I'll explain to you, then I make it short. Reaction at anode. So this one you will write separate. See, zinc S. It will give you zinc 2 plus aqueous because it's a paste is being used and have 2 electrons. But see dear, paste contains what? Potassium hydroxide. So you'll find immediately zinc 2 plus ion is going to combine with hydroxide there and it will give you zinc hydroxide. Please see, for your knowledge, you should remember all metal hydroxides are not stable. Like silver hydroxide is not stable. It will immediately form silver oxide. Iron hydroxide is not stable. It will immediately lose water to give you ferric oxide. Rust is ferric oxide. Initially form ferric hydroxide, then it becomes ferric oxide. Similarly, zinc hydroxide is also not stable. Aluminum hydroxide is also not stable. Aluminum hydroxide lose water to give Al2O3. So here also, what is going to happen? See here, zinc hydroxide, okay, will lose a molecule of water to give you zinc. Okay, so let me add. These things are not. Your book has written this portion very badly, hopeless. See here, what should I write now here? This this cancel. So what should I write now here? I'll write here this plus 2H minus will give you zinc oxide H2O plus 2 electron. All right. So now this one you write separately. So I'll write now here. Reaction at anode. What I'm going to write? I'm going to write this. Zinc. Why should you write separately? Because I have to add it. Now, in addition to, you're going to write so many lines. This 2 OH minus. It will give you zinc oxide, water plus 2 electron. Okay. So now this one you write in a bracket. Not now. After I finish the second reaction. Then reaction at cathode. At what is the cathode here? Mercuric oxide. Mercuric oxide. Oxidation state of mercury is +2 here. So I'll write now here. Hg2 plus O2 minus. Yeah. Hg2 plus will take 2 electrons. It will give you mercury. I'll write there. Okay. Then what will happen to O2 minus? See, O2 minus is going to react with water because it is a paste to give you what? 2 OH minus. See, I'll add it now. It is HgO plus H2O plus 2 electron is equal to Hg plus what? 2 H minus. All right. So please excuse me, huh? I'll do some change here. I'll write it again, huh? I'll write it. Don't worry, don't worry. So I'll write now here. Reaction at okay. I'll write now here AgOS plus here you write aqueous. No. You need not write also. You will find difficulty. This. So I'll write here air. So I'll give you Ag air 2 H minus aqueous. Okay. Yes. Sorry. Now overall reaction. It's a very interesting thing here. 2H minus 2H minus H2O H2. 2 electron 2 electron. So right now here zinc S HgO S. Here and right now HgL plus zinc oxide S. Oh, this is S. See. Okay. So this is overall reaction. So what I have revoked? How many steps? 2 steps. Nah? So I'll write this one. This is for your only for your information, which you are going to write separately. Zn you Zn 2 plus equals 2. Then I will write Zn S. Oh, sorry. Zn 2 plus equals 2 H minus will give you Zn H. Then Zn H. This is S more. So it will give you ZnO S then water. Okay. So in that case, I'll write here Zn S plus 2 H minus, you'll write here now ZnO plus H2O plus 2. So first one you write this one and this one you write separate. This one. This should be in the bracket. So this is only for your understanding so that you should not feel that no chemistry is behind this. So I'm going to keep this equation, rest I'll remove. Okay. Then please write. It produces a cell potential of 1.35 volt. Okay. So we write now here. Mercury cell produces at mercury cells or button cell produce a constant voltage. So my sentence is not complete. This question is very popular. Why it gas constant voltage? See here. In dry cell, you have found no in the main equation, electrolyte ammonium was present. See here. We have used potassium hydroxide as electrolyte. See, in first step, zinc has per mole of zinc uses 2 moles of hydroxide. In second reaction, same amount of electrolyte again given back. So the concentration of the electrolyte remains constant. And in that case, what is going to happen? In that case, you'll find is going to give a constant voltage. Please don't think that I'm quoting it from any religious book. Okay, none of the religious book I have read till now. Okay, why? We'll explain through our Nernst equation. See, Nernst equation says what? E cell is equal to E0 cell minus 0.059 by n log Kc. See here. In this case, what? Kc is equal to what? We know it is in the concentration of electrolyte at anode and concentration of electrolyte at cathode. Okay, see here. Anode has taken 2 hydroxide, cathode has given back. So is it not the concentration of both of them is same? So what is going to happen now? We'll write now. E cell is equal to E0 cell minus 0.059 n. Sorry, 59 n. See here, same concentration. So if I write 1 and 1, so what will get now? E0 cell is equal to 0.059 n into 0. So this portion is 0. See what is remain there? Only standard electrode potential. Standard electrode potential is a constant. This value will never change. So because of that, it gives a constant voltage. So we need not express so many things in your exam paper. Because I never doubt the knowledge of your teacher. But they say, because in the final equation, electrolyte is not present. Should it be the reaction like that? One by mistake also may not write. So what should I write now here? Mercury cells or button cells produce a constant voltage because the concentration of electrolyte does not change, finish. This is the most scientific way of explanation. And this is the explanation. Okay. So you need not write also this one. Because half of you will remember, half will not. And little learning is dangerous. Okay. Now, wait, let me tell you. This cell, other cells are also there. So many cell reaction I will not do all at a time. Because you know your brain capacity and you are more confused than fused. And Friday, I'm supposed to have a class with you. So this Friday, I'm not going to take the class, but no chutti. Friday's class I'll take tomorrow. Okay? Because I have to finish this one. Then after that, chemical kinetics, I will not spend so much.